Hi, this is Dylan Loudon from Tuckman Geospatial, and I'm going to be uh, demoing and walking you through the TerraCount tool for Merced County. Now, TerraCount is a uh, land use and carbon planning tool, and what it does is it allows the user to define a number of different parameters for a scenario, uh, from agricultural activities to land use changes, and then it processes all of those parameters and tells you um, all about the effects of the scenario, the co-benefits, the land use changes for a number of different benefits. And it outputs a number of tables and plots to describe the effects of the scenario. So what you're looking at here is the TerraCount website, which is a web app and describes the overall tool, the different greenhouse gas activities that can be applied, um, broken up into categories, as well as the co-benefits that the different activities impact and affect. Um, so on this front overview page, there are a couple links. Right now, it's just to the TerraCount manual, but there will also be a link to the GitHub repository when this website is finalized. Um, so if we go and click on the manual, it will bring us to this pretty comprehensive guide on how to use the tool. Um, if we go now and take a look at the table of contents, we have the introduction and the overview, along with related documents, which will have links um, to the overall report, as well as other important documents. What we're going to focus on is the background, installation, and running of the tool. And we will also take a look at uh, like the input parameters to the tool and the tool outputs. And most of that we will look at in the actual tool interface, and we'll just briefly go through this tool manual. Um, so to install the tool, you have to go to the GitHub repository, which will be public, and download all of the Python scripts and toolboxes in that repository. Um, you have to have either ArcMap or ArcPro to to download the tool and use it. We recommend ArcMap 10.5 uh, or ArcPro 2.0. Here's a little overview of how the tool works. It takes a bunch of data that we've already pre-processed and included with the tool. That's land cover data and development scenarios and um, a huge amount of other spatial data, such as watershed boundaries and uh, stream proximity. And the tool takes all of the parameters defined by the user and it does a whole bunch of random selection and uh, data crunching and carbon calculation to come up with these reports, which are the outputs. Um, this is what the graphic user interface for the tool looks like, and we will be looking at that very soon. Here are the installation instructions for TerraCount. So first we're going to want to go to GitHub, and the GitHub repository looks like this. It has all the Python scripts and a couple toolboxes, one for ArcPro, one for ArcMap. And if we go to the bottom, there's also a README, which has um, the same information that we were just looking at in the tool manual. It has links to the toolbox and the supporting data, which also needs to be downloaded. And it has some system requirements. Now this tool and the data associated with it um, includes some pretty large tables. So we really recommend 16 gigabytes of memory. And if you're using it in ArcMap, then you have to have 64-bit background processing installed and enabled. Otherwise, it might run out of memory if you're in a 32-bit. Yeah. So first, we're going to want to download the GitHub repository and just download a zip. It should be pretty quick, and then extract it to wherever you want on your computer. We'll add the toolbox into ArcMap in just a minute. And then secondly, we want to download the master data, which is just a zipped folder. Um, so we'll download that, and just like the GitHub repository, you can unzip that wherever you want on your computer, and um, we will identify the path to it when we use the tool. Okay, so system requirements, we're downloading and installing the tool. There's a little bit more detailed instructions on how to install the tool, but I'll explain it in this video. And next we want to add the tool to Arc Pro. This is my Arc Pro window. Over in the catalog area, there's a toolbox menu. We're going to right click and add a new toolbox. So I downloaded and extracted the GitHub repository to here for said tool. So if we open that up, we'll see that there are two toolboxes, one for Arc Pro and one for ArcMap 10.5. So we'll just click on the Arc Pro toolbox, hit OK, and now we've added it. This is the actual tool, the script that we run that calls the other script. If you right click on it, you can view the metadata, which will give you a lot of information about the tool. Some of it gets pretty in depth about the different parameters and aspects of the tool. And if we double click on it, we will open up the tool itself. And in order to run the tool, we have to identify at least a couple parameters. We need to choose an output folder. I'll just output it to a temp folder. Now, when the tool runs, it creates a new folder every time you run the tool in the output folder. And the name of the folder that it creates is just based on the time and date that was ran. So after you run it, you can go and change the name of a scenario run to something that's more descriptive, if you'd like, or organize them by time and date. And then secondly, we want to identify the data root path. And so that is this master data folder, which was the second thing that we downloaded and extracted. So just find the master data folder and hit OK. And so you can run the tool like this with no other settings set, and it will generate results. But you're not changing anything from the baseline unless you make other changes. So for this run of the tool, we will add, let's go through the parameters and just go ahead and add some. This is an option for a conservation mask. And what the conservation mask does is you go draw a shapefile somewhere and you save it, and we choose a shapefile, and anything within that area during the run of the tool will maintain its 2014 land cover. Um, if we didn't use the conservation mask, then that area would change to the 2030 land cover. So this is a way of forcing whatever's inside that mask to not convert to a different land cover type. And so we'll go throw in a feature class that I have lying around. I think this one. And if you want to use a custom processing area, you can supply a shapefile or feature class for that as well. And what that does is that if you use a shapefile or feature class for the custom processing area, then for the whole run of the tool, it will just do apply the activities and report for that small area. So if you don't add any custom processing area, it'll run the tool for the whole county, which is over 1 million acres. And that can take a long time if you have all the options selected. Or if you want to look at, let's say, a specific watershed, you can add in a watershed boundary, and it'll just run the tool for that area, and it'll be much, much faster if you're trying to look at something specific. We have a couple options for custom development scenarios. If we open up this drop-down menu, we can have no custom development options. Um, we can have this creates custom scenario. And what that does is that if you add a shapefile that represents building footprints, it will create a fourth development scenario using those footprints, and it'll be separate from the other three. The other three development scenarios are the reference scenario, which is the like the baseline scenario. There's the Merced preferred scenario. Then there's the max infill scenario, which uh, has the smallest building footprint. And if you choose this custom scenario, it will to all the reporting tables, it will add a custom development scenario reporting field. Now, if you choose this bottom one that adds on to reference development footprint, it will just add whatever shapefile you give it to the reference development scenario. Um, so if you think, okay, we think that these like few parcels are also going to be developed in addition to the reference scenario, then you can choose it, and it'll just increase the footprint of the baseline. So we'll add a custom scenario, and if once you choose that, it pops up with this new parameter where you have to define the mask that you're going to use for that. So we have this testing mask. We'll give it that, and now we have a bunch of different options for land use and agricultural activities. So we're gonna pick some of these. We're gonna use riparian restoration. Let's do some of that at 13,000 acres in the county. And if you hover over this little information bar for any of the parameters, it'll give you some information on the right about what what the activity actually does and what the requirements are. Let's do some oak woodland restoration, maybe 45,000 acres. And oak woodland restoration finds grassland and then turns it to forest based on some suitability requirements. Let's add a couple more. Mulching. Let's do mulching at that amount and replace synthetic nitrogen fertilizer at 18,000 acres. So this is where you enter the number of acres that you're trying to use. And then below it, we have this year that the activity begins. And that can be anywhere from 2014 to 2030. And then we have the years to full mulching adoption. So that's how many years it takes um, for those 5,500 acres to adopt mulching. Basically, if we set it to 5 years, then the first year we have 1,000 acres that are using it. The second year we have 2,000 acres. Then in year five, there's 5,500 acres that are using it, and they use mulching for 10 years, and then they start uh, to unadopt it as well. For urban tree planting, it's the only activity that's different than the others. Um, all it has is urban tree planting canopy increase. Um, so it's how much the tree canopy increases in the urbanized areas. The default is 1%. and the maximum is 5% or 0.05. Once you've selected your activities, if we come down to this treatment mask, um, the treatment mask is like the custom processing area mask, except it doesn't limit where the tool runs, it just limits where the activities can be applied. So if you say you want 10,000 acres of riparian restoration, but you just want it to be in a certain area, then you can supply a treatment mask. I don't think we're going to use one for this run of the tool, but it can be helpful for more targeted activities. And then we have a number of options for avoided conversion. Um, I think there are 14 different avoid conversion options. And basically, what these do are they prevent a land cover class from converting to another land cover class in 2030. So let's use annual cropland to urban as an example. If we want to stop annual cropland from converting to urban in 2030, then we just tell it the number of acres that we want to avoid conversion. Yeah, and so this, so we can do it. We can just set a couple of these. Um, let's see, maybe irrigated pasture to urban as well. And so you have 9 different boxes where you could use up to 14 of those if you so choose. Um, Next, down at the very bottom, we have these 2 uh, reporting options. Now, they both take a long time to run. If you run both of them for the whole county, it could add up to 4 hours or more to the running of the tool. Since I already ran this before, we might as well check them. And the this next option, generate Plotly plots, the tool has the ability to automatically generate charts and plots at the end of the tool, but from the like reporting tables that it creates. But you need to go to plotly.com and sign up in order to get an API key and a username. So if you go and do that, you can enter those here, and the tool will check just in this graphic, um, in this interface, that the API key is correct and the username is correct and that it will work, and it will tell you if it doesn't. And finally, we have this reporting units option, so you can choose whether the reporting tables that are output at the end are in acres or hectares. Um, and the very last option is this ignore adoption cap option. And what that does is if it's checked, it removes the limit. So like right now, riparian restoration adoption is limited to 25,000 acres in the county. Oak woodland is limited to 52,000 acres. Um, and these limits were based on a number of different variables, including like research into how many acres are already using these activities. But if for some reason you like to add more than the limits are set, you can check the ignore adoption cap, and you'll be able to enter up to 1 million acres in each activity. So once that's all set, we just go ahead and run the tool. Now, while you're running the tool, you can pop open this like reporting window, and it'll tell you what's going on in the tool, that it's added certain activities to the list. It'll tell you what your parameters were, and it will tell you what it's doing. And it takes a little while. It has to load a couple large tables, which takes a few minutes, like 4 or 5 minutes. Um, so we're going to move on because we've already ran the tool, and we'll just go ahead and look at the results. So this is what the tool looks like, what the output folder looks like. It has a number of different tables, all of which are described in the tool manual, which I guess we should come look at for just a second. Um, so there's a number of terms that are uh, described and defined in the tool manual that are helpful for understanding exactly what you're getting out of the tool. The tool manual goes through a lot of what we just talked about, which are the all the different parameters in that graphic user interface and what they do to the tool. But since we've already talked about those, I think we can just go past them. It talks about each of the activities and what the suitability requirements are and what the activity actually represents. It labels all the avoided conversion possibilities. And it talks a little bit about the different types of avoided conversion in the tool. Some that's built in, and then the avoided conversions that we could choose from that list, and how the development footprints are applied. It also mentions the adoption cap, which we looked at. Has links to the activity sheets for each activity, and it talks about the hierarchy of inputs and how they're applied behind the scenes in the tool and the order in which they're applied. Um, so down here, we have some graphics that show the main folder and all the different files in the folder, um, the tables, and then if you choose the plotting functions, we have a couple extra folders, one for the tables used in the plotting and one for the plots themselves. Um, so okay, the log file is one of the more important files in the folder. I should just mention that if you do supply shape files and feature classes for like the custom processing area or the conservation mask, the tool will uh, project and export the shape file that you use to this output folder as well. So if we go down to this log file and we open it up, we see that it has a lot of the information that we saw when we started running the tool. It tells what the inputs were, what the feature classes or shapefiles were that you used for some of the parameters, and it goes ahead and it says what all of your like parameters were in the tool. So we chose a certain amount of riparian restoration, a certain amount of oak woodland restoration. We didn't do any cover cropping, and once it goes through all of the uh, all of the parameters that we input, it tells us about the selection. So it will tell us, okay, we chose 1,300 acres of riparian restoration. There are 23,000 eligible acres, um, and it tells us how many acres were actually selected for that activity. And because it selects the areas by groups, it can be a little bit above or below the exact specified acres. So it tells us that selection about the selection process for each activity, and then it tells us which CSVs were exported. So I think it's a good time to look at one of the tables. Now we don't need to look at all of them. They're fairly similar. Well, let's look at the activity acres table first. What this table tells us is how many acres were selected for each activity: urban tree planting, replacing synthetic nitrogen fertilizer. This is a nice little table to just make sure that the run of the tool did what you expected it to, activity wise. Um, but let's look at this FMMP table, and this is the uh, farmland loss table. What we see here is that we have the FMMP class, which are for this tool: local importance, prime farmland, statewide importance, and unique farmland. Um, and then what it tells us here is it tells us uh, the hectares of each class in 2014, so how many hectares of each were in the county. And then each of these fields tells us the how much of each class was lost uh, due to development. Uh, and it can be a little bit difficult to read, but the way that we read this is hectares loss for avoided conversion from irrigated pasture to urban. So by avoiding conversion from irrigated pasture to urban land cover, we actually prevented the loss of 31 hectares of farmland of local importance. So these avoided conversion fields uh, always report in um, it's a like a double negative. Whereas if we look at this hectares lost for the baseline BAU, what it tells us is that under the baseline development scenario from 2014 to 2030, uh, 1,000 acres of local importance farmland was 1,000 hectares was converted to an urban or developed type. 870 hectares of prime farmland was lost, and then 490 hectares of statewide importance. Um, and so all of these fields are described in the tool manual, and it can take a little bit of practice in order to read them uh, and understand exactly what they mean. But it doesn't take that long. Finally, if we look over here to the hectares lost treatment BAU, this is uh, this is how many hectares of those different classes were lost underneath the treatment scenario. So this is the baseline, but with all the activities applied, um, such as the avoided conversion. Uh, Primarily avoided conversion is what affects this. And so what we see is that there's a lot less loss of each farmland type under the treatment scenario because of the activities that we applied. So now we'll just go take a quick look at the plots that the tool can make. Um, yeah, I guess we can go through each of them really quickly. I'll just describe what they are. So this shows 2014 water demand, um, which are the acre feet of water demand by land cover class that uses water in 2014. We'll look at all the 2014s first. These are like the baseline amounts. This is the tons of air pollutant sequestered annually. Um, and so it's summed up for the county for each air pollutant. CO2, NO2, O3, particulate matters, and then SO2. This graph shows the hectares of general land cover in watersheds with important aquatic habitat. So these are watersheds that have been defined by the Nature Conservancy as being important. This is the 2014 crop value in millions of US dollars by crop type. The 2014 hectares of important farmland types, which we were just looking at the table of. The land cover, general land cover in the 100-year floodplain for 2014. The overall land cover in 2014 by more specific land cover classes. The 2014 land cover in areas important for natural resilience, general land cover classes. The amount of nitrate leaching by crop type. The amount of nitrate runoff by crop type. The specific land cover in priority conservation areas. The land cover in highly visible areas. The land cover in areas important for social resilience. The 2014 resistance to species movement in essential connectivity areas. So low resistance means it's easy for animals to move. High means that it's very difficult for animals to move across the land cover. This is the resistance to species movement countywide. Um, 2014 watershed integrity. Now this is described in the methods document, how these are calculated, but degraded, important riparian buffer, and natural catchment are the three classes. And then we get into the 2014 to 2030 change uh, plots. So these tell how the benefits have changed from 2014 to 2030, uh, and I think most of them are compared between the reference scenario and the treatment scenario. And the reference scenario is like the baseline 2030 development scenario with no activities applied, whereas the treatment scenario is the 2030 baseline scenario with all the activities applied. So what we can say is that from 2014 to 2030, there's about 24,000 acre feet less water demand, primarily from loss of annual cropland, whereas in the treatment scenario, there's almost 45,000 uh, fewer acre feet per year of water demand, based on probably riparian restoration and avoided conversion activities that we chose. This is the 2014-2030 change in air pollutant sequestration between the reference and the treatment scenario. The land cover change in watersheds with important aquatic habitat. So in the reference scenario, there's 1,500 fewer hectares than in 2014. In the treatment scenario, there's 25 fewer hundred hectares than in 2014. And there's a lot more natural land cover in the treatment scenario than the reference. Um, so this is the change in carbon reduction. Um, the reference scenario reduces carbon by 1.5 million tons, whereas the treatment scenario reduces carbon by over 3 million tons. These are the carbon reductions for the treatment scenario for specific activities that we chose. This is the change in crop value. So there's there's more crop value in the reference scenario than there is in the treatment scenario, but both have more crop value than the 2014 here. Um, this is the 2014 to 2030 farmland loss, which we're looking at in the table. But like 1,000 hectares of local important farmland lost in the reference scenario versus 600 hectares in the treatment scenario. And that kind of relative change looks like it carries through the other classes. The change in land cover in the 100-year floodplain. Uh, so this is just reported for 2014 to 2030, but it's the amount of groundwater recharge lost between the reference and the treatment scenario. So due to development um, and urbanization, 60 acre feet per year of groundwater recharge is lost in the reference scenario versus 25 acre feet per year in the treatment scenario. That's a little hard to read, but this is the change in specific land cover for each scenario. The land cover change in areas important for natural resilience. The change in land cover in priority conservation areas. The change in land cover in highly visible areas. The land cover change in areas important for social resilience. The change in resistance to species movement. So in the reference scenario, there's a loss of low resistance movement land cover between 2014 and 2030, whereas in the treatment scenario, there's 4,000 more hectares of low resistance movement land than in 2014. We have the change in nitrate leaching, so the tons of nitrates uh, leached goes down in both scenarios, and the same with nitrate runoff. You can see the change in watershed integrity from uh, primarily riparian restoration. There's a lot more riparian buffer um, and less impacts to natural catchment. And then finally, we have the acres selected for each activity, which was that first table that we looked at. And at the end, we compare the N2O and CH4 emissions net of CO2 removals for each scenario. Um, and then we compare the N2O, CH4 emissions, and CO2 removal flux for each scenario. And for the treatment scenario, we have the total emissions reductions and CO2 removals achieved at 2030 from 2014 from the activities uh, that we chose to use. So I hope that is a good introduction to how to use the tool and how to look at the outputs. Uh, Please contact us through the website if you have any questions.